Hi, Richard. How are you doing?
I'm doing well. How you doing? It's been a
Oh,
long time.
very long time. At least 10 years, I would say.
Yeah. Oh, at least, yeah.
Yeah. But even more important question is, what was your first computer?
I actually don't know what it was, but it was some type of Tandy clone. It
Uh
wasn't
huh.
actually a Tandy, but it was I don't know, some cheap knockoff green screen, maybe about that large, it's kind of
Uh huh.
small, and all in one case with a little keyboard on it.
Okay. And how you got it or why you got it?
My dad had one. So my dad was always interested in computers, and so he had his own little auto repair shop, and he got a computer to help him. I don't know, take care of bills or something. I don't
Okay.
know, but it was sitting there, and so it needed someone to program it. So that was
Oh, so you started immediately to program.
not immediately. We had it for some number of years, and then I got a little older, and my dad gave me a book on BASIC, and I said, "Well, here's a computer. Let me try using this one."
Okay.
But we built over the my youth. I mean, we always built computers. We had for our own use, So I grew up assembling computers, and uh, my dad still has many archaic parts that don't work on anything anymore, but we used in order to build these systems. We started off with like an IPX Novell network, and then switched to TCP/IP later, and
Mm-hmm.
wired
Netware.
cat cat cables throughout the house. I don't remember if when what the original cable wiring was. Probably like Cat 3 or something, and then it switched to Cat 5. I don't remember.
Mm-hmm.
But we had so when I was young, we had enough computers in the house that we would play. Like not World of Warcraft, way before that, like Warcraft 2.
Okay.
Way back then with all my brothers, and so we would have our own little LAN and have our own games and stuff.
I started actually with the round cable, as the coaxial, and this was
Yes.
painful because you had to terminate them properly. And I had two computers, but it never worked, I have to say.
That termination just right was a little tricky.
Yeah.
Yeah.
So your dad was a programmer.
No, no. He just liked computers.
Oh, that's good actually.
Like he sort of guided me into programming because he's like, "That's a good career. You should do that." And
Hmm.
so my brother and I actually, my younger brother, just younger than me, we sat down to build. We wanted to build a game.
Hmm.
So all I knew was BASIC. So we
Hmm.
just had a quick BASIC interpreter, blue screen and
Hmm.
typing in the commands. I didn't know about functions, and I didn't know about for loops. I only knew about put pixel and basic math and things like that. So we were trying to draw the introduction screen, and we wanted it to have lightning and stuff. We had no idea how to animate anything. So it was all going to be just static. But I was like literally copying and pasting the commands for draw lines and put pixels for every brick in the screen. It was horrible. And about I don't know 30 to 50,000 lines into the thing, I burned my brother right out, and he went to become an organic chemist instead of programmer. So he was like,
Okay.
"This is the most boring thing ever," whereas I really kind of enjoyed it. So that just sort
Uh-huh.
of set me up.
And,
And my
and and did it work somehow? So at least something.
Oh no, we never got past that first screen. But my uncle came along, and he built a. I mean, he sort of redid it for us, and it had functions and loops, and it just blew my mind. I didn't know what was going on, so I knew I had to go learn a bunch of stuff. So, that started my journey in trying to figure out how these things worked and
Yeah.
build. But
But what was your first program which actually worked?
um, the first one that was used in production, I built for my dad's shop. It did all of the inventory management and estimates, work orders, timekeeping, all this kind of stuff. I was 17 at the time, and it was like the full system. We installed it down at his business, and database front end, all the all the
Wow.
bits.
Hmm.
So that was my first like real production app. Everything before that, I
But
had my
this is huge actually. It was an app which what?
real
Okay.
yeah. I didn't I didn't know anything. I just sort of learned it as I went along. So it was in C++, and I had templates all over the place, which were really cool. I was like generating all of the basically looking back on it. I was using the templates. I was basically generating all of the ORM layers of the software.
Okay.
So I would just define. I had like one big SQL file that I used for setting up my database, and then I had this one file with templates that matched each template to one of those database tables, and it would generate all the appropriate code for doing all the ORM mapping, the queries, loading the data, all that kind of stuff.
Mm-hmm.
And then and then that was made simply available to the front end
Mm-hmm.
pieces. It was only a 2-tier system. Obviously, this is
Yeah.
talking about like 1996 or 97, somewhere back there.
Okay.
So it was like a 2-tier system, but yeah, no, it all worked.
It was Borland CEO?
It was Borland. Yep.
Yeah. And what kind of store your dad had? What was it?
It's a automotive repair shop.
Ah, okay. Cool. So lots of Ford Mustangs and stuff, right?
Yes.
Yeah,
all kinds of. He still has his shop. All
Okay.
these years later, still has it. But it's general purpose auto repair. So any type of car, you can work on all types
Very
of
good.
projects.
Pretty cool. And you learned everything by yourself. See.
Yes. I ended up, so I dropped out of high school, went to college. I took some classes at college. Some of those overlapped in this time period, but mostly I learned everything myself.
Mm-hmm. And okay, and what did it? College was a computer science, or
Yeah.
Okay.
Yeah, so I started my computer science degree when I was 16, and I completed it when I was 43. Because I kept getting jobs, and so I would go work, and then I would be like, let me take some night classes. Let me do a little just. So I ended up finishing it just for the sake of finishing it, but yeah, it was.
But you started with 16. Is it even possible to start college with 16?
No, I had to drop. I dropped out of high school so I could do it.
Okay, this wouldn't be possible in Germany, I think.
Yeah,
Okay. Okay, you can start. You can start college without completing a high school.
Yeah.
Cool. So is even a high school mandatory, or you can just start at a college?
Well, I mean, I would recommend everybody go to high school, but in my case, the way that it worked was that you could go to college. Either you have to achieve a certain age and go to college, or you have the permission of your principal. Basically, it's like the school has to let you do it. So we have today, my kids are in high school, and they have what's called dual enrollment, which lets you take some classes from college and some classes from high school. That's
Interesting.
totally possible. The other thing you can do is you can take a test that they call like the GED or the high school equivalency, and you can take that test and basically test out of high school and then go to college.
Wow.
Or in my case, what I did was I dropped out of high school and was homeschooled for a few months. That made my mom basically my principal, and then I could go to college. So
Okay, cool.
that's what I ended up doing. There's a little loophole there we use.
Okay.
But, yeah.
And you had lots of jobs. You said were computer science jobs, or
yeah. So I built this program for my dad. I served the mission for my church. Then when I got back, I got a job out in Utah for this little company called DTI that did software for newspapers. And then after a couple of years of that, I was like, I'm going to go back to school. So I went back to school. Then I was doing a new version of the program for my dad, this time in Java, because I learned Java at this other company. And then
which Java version was it?
What's that?
Which Java version?
I think it was 1.4.
Wow.
I think it was.
Okay, this was okay.
And then I sorry, I lost my train of thought. So I was doing that, and while I was doing that, I started this open source Swing component library enhancement project called JGUI, and then about the same time, Sun started their, I don't even remember what we called it at the time, like JDNC, I think it was, right? Java Desktop Native Components, something like that, JDNC, and which is what became Swing Labs. So it started off as JDNC. And when I saw that, I was like, oh, that's better. Instead of me doing my own project, let me just contribute on theirs. So I started contributing to that. Then Amy Fowler sent me email saying, hey, we have an opening. Think you should apply. I was like, okay. And then that's how I joined the swing team at Sun. Just through that.
But Emmy, she was incredible, right? She was like I don't know, she was an architect, like
Yeah,
the
she's awesome.
UI architect, right?
Yeah, yeah. She's awesome. I'd say Amy and Hans and Scott and we're kind of the original core, I think, to
Hmm.
um, that team. But yeah, no, Amy was super awesome and gave me an opportunity. And which I was like, sorry, Dad, good luck with your program. And I went to Sun Microsystems at that point.
Okay, but
Switched.
there was with the program was a lot to do, and wasn't like finished. I mean, you know.
Oh, the first one, the first version I did in C was done. The revision was not done. I learned from that experience, the second system effect, where the
Hmm.
second time you do a program, you try to polish it and make it perfect.
Hmm.
I suffered from that in that second version of the program. I tried to make everything perfect instead of just getting it done. So
Okay, was
that's
it
it.
applet based or
No, it was desktop.
that's a swim? Okay,
Yeah.
and you said you contributed to the Java desktop native whatever.
But yeah.
Was it open source?
Yeah.
Okay,
It was the name of the project before we called it Swing Labs.
okay.
It was JDNC. Or Swing. Yeah.
And JGUI, what is JGUI? Was it like
Yes. I just had some components. I don't remember where I was hosting it. SourceForge, I think.
mhm.
It's just my own project that I started, and I just started putting some components on there. I don't even remember which ones I had.
But how you got the idea to start a project, you know? So I mean,
I don't know. There were gaps in what the Swing components would do that annoyed me, and so I was like, I'm going to write some code to do it.
mhm,
And I don't know. I just thought I'd do it as an open source project. So
mhm. Okay.
cool.
And Swing Labs was already what is the purpose of Swing Labs?
So the purpose of Swing Labs was to sort of fill in. So there's a certain cost that was involved to creating a component and sticking it into the core Swing libraries.
Mhm,
You have to support it forever and ever. You can't innovate very quickly. There's the maintenance, multiple branches, all this kind of stuff. So the idea was that let's create an open source project that has a whole bunch of additional components in it that people
mhm,
can pick up and use. Lower barrier of entry, because remember at the time Java itself was not open source.
mhm,
Source was available, but not under an open source license. So the only way to sort of evolve and develop Swing was really internally, and so the idea was let's create this external project where we can create new components and extensions to components and default cell renderers and all that kind of stuff
mhm,
for
mhm,
JTables, things like
mhm.
that.
And you worked full time on it. You
Yeah,
with and the others. Okay. This was JDK 1.5. I already assume, right?
it was right around there.
Okay.
Yeah, I don't. It was in 2004. I think I joined in late
Well,
2004.
okay, a long time ago. So and and you worked. You had to relocate to Sun
Yeah.
headquarters, or
Yep.
okay.
Yep. Yep. Went to Silicon Valley.
It was the is it Palo Alto, right? No,
Well, they were in Santa Clara, so
Santa
I
Clara.
was
Okay.
I was working
Hmm.
out of the Santa Clara office. I mean, Sun had several different campuses, but I was working in the Santa Clara office, which is where Swing was.
And you enjoyed, the work
Oh,
environment. And,
amazing!
yeah.
Sun was a great company to work at. I mean, as far as like as an engineer, engineers were like in charge. At least that was my experience inside the Java team. It's like engineers were the ones who were like, "This is a great idea. Let's build it. Okay, let's build it." We would get things together. We would build it. We put it out there, and so it was very very much an engineer friendly company. For the first time in my life, I was making a decent salary, uh, and the people were just amazing, right? Like Amy Fowler,
Hmm.
Jim Graham. I mean, they had been things that I had only read about on websites or in magazines at the time, right? That's how we did things. It was about the history of computing. They had lived it, like
Hmm.
Jim Graham, I think, started at Sun in 1982 or 1984 or something like this. And so to be able to work with somebody like that who has been part of that whole computing story from that time on was just phenomenal. Hans Muller was incredible as a mentor, just teaching me how to do API design and how to think about those problems and stuff like that. So it was just a really tremendous opportunity and just really fantastic group of people.
Hans created also the JCP, the Java Desktop JCP, right? So Hans, he had JSR. Not JCP, JSR. What I meant,
Oh, probably.
296 or 295. There were two actually, which started like the Java Desktop JSR. There was, I think, from Hans once.
Yeah, there was one for data binding, and then the other one, I think
Yeah.
295 maybe was the data binding one.
295 and 296. There were two.
Yeah,
295 is data
yeah.
binding, and 296.
I was
Were
there for
interesting one.
that whole experience.
hmm And what happened with Swing Labs?
Oh gosh, I don't know.
Or what you did? So you left Swing Labs because
No.
one.
So we worked on that until JavaFX came along, and
hmm
then uh, there was a big reorganization internally in terms of our priorities and projects, and we all started working on JavaFX, and then for about I don't remember. I've forgotten the time period, but it was a few years, and then maybe like a year and a half or 2 years, something like that. Then we some people like it was around that time that Hans left and went to Google. Well,
hmm
actually, he went to Adobe, and later he ended up at Google. So he went to Adobe first. Shannon Hickey, who was also
hmm
one of the leads on the Swing team. He left for Adobe, and Hans went to Adobe. So uh, there's sort of opportunity there for me, and so I became a lead on the JavaFX team, and then eventually chief architect on all client Java a few years later.
Oh, I
So
didn't knew that. Okay.
yes, so all of because there was as things internally were arranging themselves, eventually the Java client team was consolidated with the ME because it used to be back in the day that ME was a completely separate org, but
hmm
all that stuff started to get consolidated and rearranged. So at one point I was just doing my thing, and at one point it's like, oh, Java ME reports into Java client and everybody else, and I wasn't the manager. I was just just an architect, just an engineer.
hmm
So, but Jasper and I, and then we hired a couple other really great people who used to be on Eclipse on the SWT team, and and anyway, that was sort of the core group that
Jasper
eventually.
Ports was also an incredible designer. I remember.
Oh yeah,
Yeah.
yeah. I still work with Jasper. He's at Hashgraph with me,
Oh,
and
very good. Okay.
10 years ago.
Co-
Yeah.
uh, cool stuff. So the JavaFX, the beginning was really interesting because it started as F3. You know, remember this form follows function. It
Yep.
started from nowhere, and then
Yep.
there was the JavaFX script, which was the first attempt.
Yep.
And I kind of like that because everyone wanted to do something different to Java,
Yep.
and back then it was very popular on conferences to talk about how to not multilingual. What was polyglot or
Paula.
polyglot?
Yeah.
And it's okay. Now we have JavaFX script, so we have a little bit no polyglot. So and what I did, I actually wrote a book about JavaFX script. Um,
Yeah.
and then it was cancelled. So my book was almost done, was cancelled. Okay, then there is no book. And but I have to say, the JavaFX idea, I really liked actually the idea. From performance was not that great, but the idea was good actually.
Yeah. So it was. Oh man, I could talk for a very long time on backstory and everything that went into JavaFX, and you know it was very. It's an experience I will never forget. Um, so
Yeah, what was the backstory? Because why it happened out of nowhere? So I
I can't,
remember at one
give you
conference,
all,
there's so
I can't
like,
give you all the reasons, but I can give you some. So one of the things that happened. So Chris Oliver, who started F3,
exactly.
right? Really smart guy. Um, he was at C Beyond, which was a company that Sun acquired. As soon as Sun acquired him, he started sending, basically pitching F3 to everybody in the company, and it took hold at one of the higher levels, one of the executive levels, and so it was like, oh, you guys have to do this thing. The problem with it was that it was basically saying we should stop doing Swing development. I mean, in order to resource it and everything else, the argument was stop doing Swing, don't support all the people who have built applications on top of Swing. Instead, we're going to focus on trying to compete with Adobe on Flash.
Mm-hmm.
F3 was explicitly competing with Adobe on Flash. The problem with that is that we were in sort of the classic innovator's dilemma zone where,
Mm-hmm.
we already had a huge number of people who were using Swing. That's where our success had been. To abandon all that and move into a totally different direction, incredibly hard. And it turns
Mm-hmm.
out a dead end because Flash was dead a few years later. I mean,
Mm-hmm.
if we had pursued that model, it wouldn't have worked.
Mm-hmm.
And so it's a whole different thought to go into, but that wasn't going to work. So that's why when we ended up leaving JavaFX script and coming
Mm-hmm.
back to Java, the point of that was to enable Java developers to benefit from this new library framework. Because we really had two options. One was to just abandon JavaFX entirely and go back to Swing and start enhancing it, because the market that language had been aimed at wasn't going to materialize.
Mm-hmm.
So the decision was that we were going to try to do something that we could then bring to Java developers, so that Java developers didn't have to go learn a whole new language, and because they weren't. And they also the other problem was that Sun never should have announced JavaFX when they did. They were at a conference. They needed something. They put it out there. They shouldn't have done it. We had nothing at the time that the thing was announced. It was like a little POC. And now when everybody in the world heard it, it was like, oh, sorry, this is the future. This is what we're going to do. So they stopped doing all their Swing investments. And we had calls from people who were like, oh, we're really interested in this JavaFX thing. And then it's like, yeah, you can't use it. It's way too slow. And so it was just wrong. What they should have done was to give us the year that we needed in order to develop something that was decent that we could then actually run with. But anyway, it was classic sort of big company. And Sun at that time was sort of in its end of life. It was soon to be sold to Oracle. There was all sorts of turmoil. It was when I say I could tell you the backstory, there's a great volume to be written by somebody on all of the backstory of what was going on at that time. But I think in the end, I was really proud of where we ended up. The core essential argument was, do you have a immediate mode graphics system or do you have a retained mode graphics system? Are you doing Java 2D style drawing, or are you doing a scene graph? And are you doing 3D? You're doing 2D. And what we ended up with in JavaFX in the end was something that could freely intermix 3D content, 2D content, immediate mode content, and retained mode content all in one system. And it is fairly sophisticated system.
Yeah,
you can run with pretty good performance characteristics.
Yeah.
So I think we ended up doing a pretty good job. It was a massive project. It was a large group of people. Lots of a lot that went into it, and ended up with some really great technology. So I was pretty proud of where we ended up in the thing, despite all of the back and forths. But after JavaFX, I think it was around 2012, 2013, Jasper and I moved to the IoT team at Oracle. And then at that time, so they were trying to do this, Internet of Things, build an Internet of Things business around it. So we did that until around 2019, 2020. Somewhere in there is when I guess around, 2020, 2021. I don't know. Somewhere around there, I've forgotten, is when I came and joined Hedera. Yeah. So now I'm a blockchain guy.
Okay. From my perspective, so the JavaFX at the beginning made me really curious, but I also really liked Swing. So, there was back then, there was the Extreme GUI makeover, Java 1 Talks. You remember that, right? So they really looked impressive. And I really like, the Swing look and feel. I use Swing in projects and was happy with, basically. So I also use NetBeans Matisse and had some thoughts about data binding, how to make MVC and model view presenter and stuff like that. And And then F3 came out. So I didn't knew what it actually is. And later what I was impressed with that in JavaFX, you can basically pick a shape, whatever you like, and make a component out of that. So this is what I like. You have a rectangle, you can click on it and it worked. So I was okay, this is actually interesting concept. This is what impressed me. And JavaFX is still going strong. Right
Yeah.
now, the Johann Voss with Gluon, they are, I would say, very successful. And in the last DevOps, they presented, I don't know how to pronounce that, but this is J Tacocino or something like this. This is like, the Jupyter Notebook with
Yeah.
JavaFX. So really interesting technology. And in Germany, they have some conferences about JavaFX. So I would say it was actually a big achievement and it worked well. And I didn't even notice, what I noticed. I think back then Jonathan Schwartz announced JavaFX already. I think
Yes.
he was in charge.
He was.
Yeah,
He did
yeah,
the announcement, the JavaFX 1 announcement. I
yeah.
remember it was in some little club in San Francisco when we launched it. Did the launch announcement and the announcement of Java 1.
Okay, and then what I saw is the Java 1 announcement, and then already they said, okay, there was the store, the idea that there is an JavaFX store,
Yeah.
and also like tracking, user tracking with metrics and stuff like that.
Yeah.
And I said, okay, that's interesting. And also there was a new UI tool which was built. It was NetBeans based, but not really. It was built by one of the guy. What was the
Scene
name?
Builder. Yeah, we built Scene Builder.
Scene Builder worked.
Yeah.
But before Scene Builder, actually, I forgot about that. I use Scene Builder and built Afterburner, my own small framework with
Yes.
dependency injection on, and this
Yes.
works actually surprisingly well. And I
Yeah.
still get requests because the idea was you can design something with Scene Builder, and then use that and inject to your code whatever was generated. So I had a clean separation between generated code by Scene Builder and my own. Yeah, exactly.
Yeah.
Scene Builder was
Scene-
great.
The team that built Scene Builder was down in Grenoble,
Mhm.
and the manager of that team and the lead engineer of that team are Simone and Eric, and they both actually work at Hashgraph now too.
Very good.
But that was that was the team that built that, and they were absolutely fantastic. They're
Mhm.
great.
And the Scene Builder is still maintained by Gluon now, by the
No,
Johann
I
Voss
think
company.
Gluon is
Yeah.
doing the maintenance of Scene Builder.
Mhm.
Yeah, Johan gets like major credit for
Yeah.
contributing to all this stuff and being outside of Oracle and all that, and helping to pick that up and maintain those pieces is huge credit to Johan for that.
Yeah, and Johan is really passionate. So I had a long talk with him, and he also ported, I think, Java to Linux. He was the origin, initiator of the
Yeah,
Blackdown.
great.
Yeah, exactly. Uh-huh.
Yes.
Mhm. Okay, so now you moved to Hedera. So why and what is it?
Yeah. So the why was not very. So what happened was that on the IoT team, a couple members of the IoT team, this guy, his name is Atul Mahamuni, and just such a nice guy, brilliant guy, great to work with. He was one of the products that the IoT team built was a blockchain based application for supply chain management,
Mhm.
and he was PM for all of our products. And he that one day he's like, okay, I'm leaving Oracle. I'm going to go join this company Hedera. We're like, who the heck is that? And what the heck are you doing? Like,
Mhm.
why would you do this?
Mhm.
This doesn't make sense. He had Atul's background was in networking. He's a networking engineer. He was at Cisco and Juniper Networks, and had done various things along the way like that. And then he had joined our team, and then he was leaving. And so really liked him. He was gone for about a year and a half, 2 years, something like that. And then I was at that time I was looking for new opportunities. I was looking for a startup, and I had been looking for a startup for a while, and just because I wanted to have that
Mhm.
experience because I'd been in big companies for so long. It's like I'd
Mhm.
like to do something in a smaller company. And but I had very specific things that I was looking for. I wanted to find a place that had a great group of people, a place that hadn't yet made it big. So, there was still upside potential in
Mm-hmm.
working in a startup. A place that had some kind of secret sauce that was really impressive, that had and some kind of a business that had a trajectory. Right? There had to be some reasonable.
I would say Mission Impossible.
Yes, like so. I looked for a long time. I was like, yeah, I don't like that idea. I don't like that
Yeah.
idea. And so I was kind of looking around, and a tool contacted me and he said, "Hey, we need a VP of engineering," and they had been only hiring locally, but they had just made the decision that they could hire remote. So a tool reached out to me immediately, and I was like, "Yeah, I'm really interested." So I started. That was the beginning of my dive into it. Prior to that, it's like, of course, I had seen in the news all this stuff about Bitcoin, and I was like, I don't understand it at all. I don't understand why this matters. Who's doing this? A tool goes to a blockchain company. I don't get it. Whatever. I don't get it.
Mhm.
And then when he reached out to me, I was like, okay, I should look into this and see what's going on. The thing that Hedera solved almost every single issue that I had with blockchains. Like when I was investigating it, and I was saying, well, blockchains are crazy because the amount of money you have to spend to run a transaction on the blockchain fluctuates based on the price of the token. So if I wanted to run something on Ethereum, the price in dollars fluctuates based on whatever the exchange rate is between USD and Ethereum. You have to pay in the native token, and so you have to convert it. Whereas Hedera said, no. Although we do have a native token, of course, in order to run things on the network, the important thing is the fees that we charge you are fixed in dollars. So regardless of what happens to the HBAR price, which is our native token, your fees are always fixed. So it's like fixed fees, low fees, predictable fees. Anyway.
But from blockchain perspective, so my understanding is you don't need any fees. So I think basically Git, right? Git is kind of a blockchain. You can consider Git idea as a blockchain because there is a chain of immutable transactions, right? So this is all you need.
It is basically. At least some cryptographic chain of
things.
Yes, that's true. You could certainly set up blockchains where you didn't charge any fees. Exactly. But there's actually something really important about the fee system. And I think this is what nobody really understands. In fact, I'm going to plug a book that's not my own, but I love it. It's this book called Read, Write, Own by this guy named Chris Dixon. So Chris Dixon is at A16Z. And one of the things that I had always wanted to know was, like, why are these venture capitalists getting involved? Why are the VC firms saying the blockchain is an interesting area? Like, what is this really all about? Mm-hmm. The argument that he lays out that I found very compelling is that if you back all the way up to the early days of the internet, we had the internet, which was just a way to send packets of information from computer to computer to route it appropriately. That's the internet. And on top of the internet, we built a couple of protocols that really took hold. One was email and one was the web, HTML. Mm-hmm. And those two protocols built on top of the underlying internetwork, right? Mm-hmm. And those protocols were absolutely free. Like anybody could set up an SMTP server. Anybody could set up a web server, totally decentralized. It wasn't in the hands of any company. And that wasn't necessarily the case. If you remember back in these days, we had AOL built on top of email, but AOL also tried to centralize the internet onto itself. Like it was the internet for people, right?
Yeah.
This was sort of the idea. They were trying, these companies were trying to centralize because if you can, so every network, including email and web, benefit from network effects. Mm-hmm. The more people you have doing email, the more valuable the network is. The more people you have with web browsers, the more valuable it is to run a web server. The more web servers, the more valuable the web browser. The two together create this sort of harmony, and they sort of together build up that effect, right? And the network effect grows non-linearly. It's at least exponential. And it's just, so the more participants you have, the stronger that network effect. So now the question is, who captures the value from the network effect? Mm-hmm. In the case of those early protocols of email and web, the people who captured the value of the network effect were the people who were on the edges of the network. Mm-hmm. So it's the people who wrote the web servers that captured the value, or the people who wrote the apps using the web servers that captured the value, right? Mm-hmm. It was Amazon. For the people who On email, it would be email clients, or it would be or even more so, not the email. I mean, there was value captured by email clients. Still today, people build startups where they charge money for email clients.
Mhm.
So it's like
And spammers, of course, right?
yes, of course. And then it's also the people who build on top of the protocol who are sending the email who are capturing value. The point is that the network effect of the value of the network is not captured by the network owner, because there is no network owner. The value is captured on the edges. You fast forward and we talk about social networks, X or I would say Twitter because it was Twitter at the time, but like Twitter or Facebook,
Blue Sky right now.
yeah, right. All these guys. So especially if we wind back and look at it in those early days when Facebook was starting, when Twitter was starting, they were trying to create their own network. And it was a social network. And we had a social network protocol at the time called RSS. Never took off. And it's an interesting, and all this stuff is in Chris's book. I'm just like restating what he wrote. So none of this is my own genius original insight, right? In fact, my eyes were totally opened to what had happened when I read his book. I didn't recognize it at the time. But you look at these different networks, they're creating their own networks, a social network. And they were able, originally, you remember Facebook had Zynga, and Zynga was like, they had the Farmville with the cows, and everybody was going on Facebook and growing their cows. And 10% of the revenue of that network, of the Facebook network, was going to Zynga. It is the destiny of every centralized network to eventually squeeze the people who are trying to capture value on the edges of the network will get squeezed out, and all the value will be captured by the network itself. Today, Facebook has over 99% of the value of that network is captured by Facebook itself. It's just the nature of the beast. If you have a centralized network and you have shareholders, you have no option but to maximize shareholder return value. You're going to capture as much of that value as you can. So all that, these centralized networks are like fundamentally different than email and web, which was an open protocol anybody could use. Now, in Chris's analysis of this, he says the problem with RSS is that there was no way to compete with those centralized networks. The centralized networks were phenomenal and successful because they were going to capture all that network value, which meant that investors would invest in that, which means that they are able to hire, hordes of engineers at really high salaries in order to build that and capture that value. And if you're just a lowly protocol like RSS, how are you going to compete with that? You can't get the manpower to do it unless you had a huge upswell of independent developers who all saw an opportunity and captured it. But it's very difficult to do, to compete against those centralized networks. So the argument for so the read phase was like these open protocols. The write phase was blogging and primarily all this stuff around social networks. And then the own phase is what blockchains do. What blockchains do is they provide a funding mechanism for open protocols. And that's why they're important. You can actually create today on top of a blockchain using the funding mechanism of the blockchain and the ownership mechanisms that blockchains provide you. You could create a protocol that could compete with centralized networks. And you can get a new network effect, and you can build this thing. And it's ultimately, in my view, a huge improvement over the current situation. Instead of a company, harvesting my personal data or having to, capturing all of the value, eliminating entire use cases or businesses that might have benefited from that social graph are not able to do it. That's bad for the consumer, and it's bad for me as an individual where I want to retain my own property rights and things like that. Blockchains enable you to build open protocols that have built into it an ownership and funding mechanism that can then allow you to compete with those centralized networks.
Yeah, so what you're saying, this is like instead of having one monolith, you have more like microservice architecture where this is peer-to-peer architecture almost. I don't know whether you remember Jaxsta. You remember Jaxsta actually? Jaxsta, Sun's Jaxsta Juxtapose protocol, Well, that everyone is a node, and what you said, ownership, because we have the cryptographic, proof that whatever happened in the network, and you have a kind of a sync mechanism,
Yep.
and you could also pay per transaction. So if you like, you can get the revenue. This is what you're saying, right?
Yeah. Yeah. So blockchains, you can go to onto any blockchain and you can create your own token. And your
Hmm.
token can be used in order to do some work to interact with your protocol. So imagine that you had like RSS on blockchain. How would that work? Well, you have your RSS, but somehow you want to be able to support people who are building RSS applications.
Hmm.
So you can create some token on the chain. You can distribute that. People can exchange that with, it goes on exchanges because there's these decentralized exchanges where you can trade that token for US dollars or for other types of tokens like HBAR or whatever. There's all these open exchanges, so it establishes some sort of a value to these tokens that you've generated for your use case. And as people adopt your use case and build applications, they take a risk. They build a business on top of that use case, and then they can maybe acquire more of those tokens, which is worth more money, and then other people get involved. And if the network grows, like if the idea that you have is powerful enough, you'll start to compound. You'll start to get those network effects. And as those network effects increase, the value of the token probably increases. But that's important. The important thing there is um, that there is the value of the network is representable and redeemable by the people on the edge of the network who are trying to build stuff. That's what you're trying to do, is to create a system where the value of the network is representable and redeemable by the people on the edge of the network. And if you can do that, then you have a chance of having your open protocol actually succeed. So it's like imagine that you were going to do a social network or like a Twitter or something like that.
Spontaneous idea. So
Yeah,
I listened now to what he said. Let's imagine an open source project, right? So right now, if you're lucky, you get a star, but someone
yeah,
could pay you. A star could be associated with a token or a fraction of a token. So, and at the end of the day, at least you have a star, which is, cryptographically proofed. You can say, okay, I got the star for the project. But in best case, you could exchange it for real money. So if this thing
yeah,
takes off, you have a value. And in worst case, you have a star, which is cryptographically
yeah.
cryptographically
It's like
signed
what
star.
you
This is the
shared with
worst possible. So actually, it is a credit. You could get the credit to open source committers, and if they're lucky, they have some money, and this would be the immediate network effect for open source committers,
yeah.
because right now they have nothing, right? So and later they could get maybe an option that in the future they can get some money out of that.
Yeah, and there's different types of use cases for tokens. So if we were to look at just a handful of use cases, one of them is like this
Hmm.
idea where in what I've been talking about in terms of there's a token that represents the value of the network of the system that you're working on. There are a lot of other use cases for tokens as well. One of them is called real world assets.
Hmm.
So, for example, on Hedera, we have actually many real world assets represented on Hedera. There is a company that's on our governing council called Aberdeen. They're a financial company out of the UK with something like $4 billion under assets under management, something like that. And they've been tokenizing a bunch of those assets. And what that means is that there's a sort of digital twin or a representation of that asset on the Hedera blockchain. And then you can trade those assets or whatever, or hold them and prove accountability right there on the chain. The value of this is that if you were to just look and you'll see that like the place where blockchains are really getting a lot of traction is in financial markets. Anytime you have a marketplace, the blockchain is a fantastic answer because it gives you this sort of trusted, immutable history of
Hmm.
all the transactions that have occurred. And they're also way faster than traditional markets. So, for example, if you're trying to transfer money from one bank to another, maybe it
Yeah.
takes 2 or 3 days for that to happen. On Hedera, it's maybe 5 or 6 seconds, and it'll
Yeah.
settle and it's done.
Hmm.
So it's like way more efficient. So anyway, so people want to digitize or tokenize because a token is nothing more than just a digital representation of some information that you can trade on a blockchain. So they will take like one person had like a bunch of like this massive diamond, and they would tokenize it into 10,000 tokens. So like you could buy 5 shares, if you will, of this diamond, and or you could tokenize real estate. There's a company called Red Swan that's doing tokenization of real estate, and of course there's all kinds of laws. And
but with the diamond, so how it works? So the diamond has to disappear basically,
no, it's just that it's just like if you were to go buy a share of that diamond today, what would you do? You would go to some company, you would pay them some money, they would give you a piece of paper, some entry in their database that says that you own some share of that diamond, right?
Yeah, but the diamond has to be somewhere then, right? So it is no.
So in this case, what they do is they have the diamond sitting in some vault with
Exactly.
cameras on it and lasers, and that's where the thing actually lives. But you are able to benefit from the value of that diamond because you buy some certain shares of it. The price of the diamond goes up.
Yeah,
goes down.
That's what I meant. So the company has to lock down in a vault a diamond, and exactly. So
there's a company that
because
does that.
digital twin means so the real thing is closed. So it's no
yeah. Yeah, exactly. So the and of course it's not our company that's doing it.
No.
We provide the network. Everybody else is built again. We provide a network and we extract very little value from it. Most of the value is from the edges. It's the people who are building the applications on top of it. It's like
but from technological perspective, what you're doing is more or less Git or Kafka with signing, right? So this is.
I would say it's more like a distributed database with signing.
Okay.
Chris disagrees. He doesn't like it when people would describe these things as a distributed database. They would think of it. He likes to think of it more as like a distributed computer. I think that you can make the argument in either way. So essentially, I'm going to make the database argument though because I think it'll be really easy to visualize it. Imagine that you have like a database like Postgres or something else, and I have a copy of the database. You have a copy of the database.
Yeah,
we have exact copies. Exact same data is in the database. The database can have stored procedures on it. Oh, and it also has just basic SQL, right? In our case, we don't support SQL. It's totally different languages. But anyway, just giving the analogy, right? Somebody wants to execute a transaction. They want to some database transaction that they want to execute, right? What they have to do is both you and me have to execute the exact same transaction and get the same result. That's the essential part of it. And let's say that there are thousands of people, millions of people who all want to execute transactions. We need to make sure that we execute the transactions in exactly the same order. If we're going to get the same result, we have to execute the transactions in exactly the same order. The fundamental problem that every one of these distributed, so blockchain is one term that's used. I've been using it throughout this discussion because I think it's more in the vernacular. A more correct technical term would be a distributed ledger. But basically every single one of these, whether it's Bitcoin or Ethereum or Hedera or any of the dozens of others, all of them have to deal with the consensus problem. How do you get a random collection of individuals running their own database? How do you get them to sort transactions in exactly the same way and get a predictable result when you apply all those transactions? That's the fundamental problem. What Hashgraph did or Hedera did, there is a fundamental advancement in computer science for the solution of, you may be familiar with the Byzantine Generals Problem. And there are different levels of Byzantine Generals solutions. The most generic of the Byzantine General solutions is called asynchronous Byzantine fault tolerant. That is the most generic. Up until Hashgraph, there was no solution known for that problem that was fast.
I thought that this is an unsolved problem. So the
it was an unsolved problem.
So what, to the listeners, two armies, and there is one hill between the armies, right? They cannot see each other, and the two armies are smaller, and they would like to attack a larger army, which is and they only have chance if they do it at the same time. And there is a messenger, right? And the messenger has to go to has to sync basically the armies to attack at the same time. And the messenger can die, or I don't know, I can just be malicious or whatever. And I thought, if you think about this, the problem cannot be solved. And
Yep.
you said you solved the problem.
I didn't solve it. Lehman did. But yes, it
Okay.
has been solved.
Okay.
It has been solved. And nobody knows this yet, which is one of the things that frustrates me. So I'm going to be going to a bunch of normal, not blockchain conferences this year. And that's going to be the talk that I'm going to put out for every single one of them, is to describe the Hashgraph algorithm. It's called the Hashgraph algorithm. And it gives you a high performance solution to asynchronous Byzantine fault tolerance.
Okay.
Up to this point, the only way that you can get faster performance is by changing the parameters. So you could get what was like the Raft protocol is like practical Byzantine fault tolerance. But it assumes that all of the participants are honest. Maybe they're faulty or something, but they're honest, and there's asynchronous Byzantine fault tolerance says, not only am I making no assumption about the honesty of any one particular node, I'm also not making any assumption about the reliability of the network connections. They could disappear for 10 years, come back, whatever. There has to be a solution that allows you to avoid sort of this we would call it the double spend problem. In the literature for Byzantine fault tolerance, it's called equivocation, but it's where one node says one thing to one person, one thing to somebody else. You have to deal with time. In order to do that, it has to be asynchronous Byzantine fault tolerant. Lehman's a mathematician and a computer scientist. He solved this problem. It's one of those problems that like he would work on, and then he'd be like, it cannot be solved. And then it would bug him, and he'd come work on it again. He'd be like, it cannot be solved. And then one day he had an insight that allowed him to solve the problem. It's actually really relatively straightforward. The details are complicated in terms of the voting system, but not if you're used to these problems. The voting system is basically off the shelf Byzantine fault tolerant voting systems. And what he did was take away the bandwidth problem of having these votes. So instead of having, generally the problem with asynchronous Byzantine fault tolerant solutions, and the reason they're slow, is because each individual has to cast a vote, and then they also have to tell everybody else how everybody else voted. And it creates a tremendous amount of network traffic. And what Lehman realized was that if we kept track of our gossip history in a cryptographically secure way, we can make it such that every individual knows what every other individual has seen as of some moment in time, and that would allow them to do virtual voting. They don't actually have to cast physical votes across the network. They know what every honest node would vote under if they had gone through that process. And anyway, there's a white paper for that I could share with you, but it's and there's a couple good videos that you can find on YouTube on it. There's a couple with Lehman where Lehman explains it. It's probably the best thing to do. He had a few different presentations that he's done over the years on it. But yes.
But you need a precise clocks in order to make it work, right?
No.
No?
You do not. Nope.
Okay.
It is clever. You'll have to go read it. But he solved the problem. And so in our distributed ledger, what that means is that we can take an arbitrary number of transactions from the outside world up to whatever our bandwidth limits are. And we can then, so in our case, we do like 10,000 transactions per second. We actually can do higher than that, but that's what we throttle it at to keep the system stable under all, so people can't overwhelm our servers. But we have, so you can do a lot of transactions is what I'm saying. They come in, the nodes gossip it with each other. Each node runs their own their own consensus algorithm. They come to the exact same order in which those transactions are going to be executed. They execute those transactions in the same order. They come up with their new state. They send a hash of the full state to each other constantly, so after each one of these batches of transactions they execute, they do a hashing and then they send a hash to each other. They then come to consensus on the hashes. They say, yeah, everything is good. They sign a block. They produce a block. And so in this way, we are able to produce the blockchain from this set of nodes. So that's the mental model I use, is more like it's a distributed database. Each one of these computers has some storage. They have like all the account balances, the different types of tokens, who owns these tokens, all that kind of information. They have the equivalent of a stored procedure on there called a smart contract. And anybody in the world can submit a transaction to the network. Anyone in the world can submit a new smart contract, a new store procedure that we'll install on the network. Anybody can create a new account on the network. Anybody can trade on the network. All the stuff is all automatic. We don't have any say in what runs on the network and what doesn't. We just say we just have all the underlying software that supports it.
Mm-hmm.
All written in
So
Java, by the way. So
this will be the last question, but the what it means is that every network node, executes all the transaction, and
yes.
it has to, and this is how they sync. So it means the transaction is executed everywhere, and if it is executed at the end, this eventual consistency. So in best case, then if everything is fast enough, at one point of time, you get the state on every node is the same if everything is executed. And the only problem you have is the order, right? So this has to be the right order. So this is what this was the trick from the Mr. Lehman.
Yep.
And so, but what it means is that if you have slower nodes, you have to wait until they keep up, right? So this is a challenge, I would say.
Yeah, the threshold is 2/3.
Mm-hmm.
So we need to, or greater than just more than 2/3. So like it's not even like 2/3 plus one, but just whatever 2/3 of the network is, round it up.
Okay.
So,
Mm-hmm.
and but it has to be greater than 2/3 of the network.
Mm-hmm.
That's what you have to run with. So if you had, like, let's say we had 100 nodes, I could have 20 of them that were slow, and the network
Mm-hmm.
would still just keep cruising along.
Mm-hmm.
The slow guys either catch up or they fall behind and have to, what we call, reconnect or resync their state from other people and then try to process again.
Okay.
But the network will run at the performance of just more than 2/3 of the network.
And you said everything is in Java.
It's Java.
Okay. Java 21.
Yep.
Very
Java
good.
21. And hopefully sometime this year we'll get onto the 6-month cadence. So we're just grabbing whatever the latest is all the time. But
if you like, or what I would like to re-invite you back and talk more about Java now. We know how blockchain is working, so what they are doing exactly with Java, and a little bit more about Java, and maybe your team, and a little bit more about the architecture, because it sounds like a really interesting project.
Yes, it is a very interesting project, and I would love to come back and talk about how we do it.
Exactly.
There's a lot of stuff that like we've written our own protobuf generator to generate modern Java, and we are have very extensive performance profiling. Oleg Mazarov, who was on the at Sun, he was on the Java team doing performance profiling, JavaFX team, IoT. Now he's here. It's one of the best performance engineer I've ever met in my life. Brilliant.
Mm-hmm.
And so performance is a huge thing for us. Object allocation, we're really looking forward to Valhalla. There's a bunch of interesting things there that we can dig into.
And what also interests me, how the stored procedures are implemented, what it actually is. So maybe, like an Hello World example, just to give an idea, because what we can build is also interesting, not how it works, but what you can do with it. And also maybe some hardware inside, what are the servers which are running. Perfect.
Sounds good.
Where people can find you on the internet, your company, you, and
I would say that probably the best place to get started would be docs.hedera.com. Mm-hmm. If you wanted to just start doing some development on Hedera. Our source code is part of the Linux Foundation. It's a project called Hiero, Hiero.
Mm-hmm.
So we have been all of our code has lived in Hashgraph on GitHub, mm-hmm. and we're moving it over to Hiero in GitHub also, but it's part of Linux Foundation, governed by them. So that's recent.
So it's open source, your stuff.
Oh, it's all open source, Apache 2 license. Yeah.
Okay. Mm-hmm.
So it's open governance. I'm on the technical steering committee for Hiero. We meet once a week. If you go look at the Hiero calendar, which they have, you can find that. So we're part of so there's the Linux Foundation. Under the Linux Foundation, it's called the Linux Foundation Decentralized Trust. Mm-hmm. Underneath that is Hiero. So we're part of this LFDT group inside of the Linux Foundation. So they have all of the things that we're building you can find on hips.hedera.com.
Mm-hmm.
and those are our high-row improvement proposals. Previously,
Oh,
our
okay.
improvement proposals. So all the improvement, basically the equivalent of JEPs, are there.
Okay.
And you can see sort of some of the different features, things that we're building. The docs.hedera.com has everything. Oh, and there's this new thing. There's a developer playground. You should start with that. It
Hmm.
was just announced today. Boy, oh boy, oh boy. I wonder where I got the email, but I haven't looked up yet where this thing's at. Okay. Um, so it's at portal.hedera.com/playground.
Hmm.
And the portal is the place that you go in order to get an account on our test. So we have a test network and we have a
Hmm.
main network. The main network is like the production one. Test net is for development,
Hmm.
trying things out. So you go to the portal to get an account on the test net. And if you go to portal.hedera.com/playground, you should see uh, the the playground. And the playground has how to create an account, update an account, delete an account, transfer HBAR, how to submit, create new tokens and freeze them and reject them and
Uh-huh.
blah blah. Smart contracts, how to get started with smart contracts, which are the equivalent of the store procedures.
Hmm.
Um, and anyway, there's a bunch of other things there. And the playground is cool because it has like the code that's sitting there, and you can actually execute that code. You can
Okay.
modify it, so on and so forth. So that might be a good place to go check
Very
out.
good. And where can people find you? Blue Sky or Twitters or?
Oh yeah, I'm on Twitter, and it's just my name, Richard Bear.
Okay. Perfect. Thank you, and see you next time.
Yeah, it's great. Thanks. Bye.